Hi everyone, welcome back. Let's write some more Leetcode today. Today we're solving maximum number of tasks you can assign. So in this problem, the description is a bit long, but I'll just explain it. So we will be given a task array and each task has an element in it and the number represents the strength required to complete the task. And we will have an array workers, and each element in the workers array will represent the strengths that they have. And in order for a worker to be able to complete a task, the worker strength must be greater than or equal to the task strength required. And if the worker strength is lower than what is listed on task, we will be given a certain number of pills, and each number of pills, we can add the strength by whatever the strength variable is. And then we want to return the maximum number of tasks that can be completed based on the inputs that we are given. So if we look at this example, we can return 3 because all 3 tasks could be completed since this worker can do this task, this worker can do this task, and this worker can take a pill with a strength increase of 1, and then he'll be able to complete this task. And if we look at this example, we can return 1 because any of the workers can take a pill with a strength increase of 5, and then it'll be able to complete one of the tasks. However, we only get 1 pill, so that's why we can only return 1. So now that we have seen some examples, let's get to how we can solve this problem. So first, we should know that if there are more tasks than workers, then because each worker can only complete 1 task, then the maximum amount of tasks possible completed would be the number of workers, and vice versa. If there are more workers than tasks, then obviously the maximum amount of tasks would be the number of tasks. So the max tasks we can complete is the minimum between workers and tasks. Therefore, we will test the possibilities from 1 task to the minimum of workers and tasks, and we will use binary search. So if you're not familiar with binary search, I would recommend to look that up first. And when we are testing the possibilities, we will always use the strongest K workers and see if they can complete the easiest K tasks. So let's go over this example real quick. So first, since we need to know who are the strongest workers and what are the easiest tasks, we need to sort both tasks and workers. And now we can use the binary search. So left would be we try 1 task and the right would be 5 because the length are both 5. So that's assuming we can complete all 5 tasks. But right now the middle is 3. So let's first set it to 3. So now we want to see if the 3 strongest workers can complete the 3 easiest tasks. And the algorithm that we will use is we will always start with the strongest available worker and see if it can do the hardest task. If it cannot, then we want to see if we have any pills available. If not, then we return false. If there are available pills, then we will look for the smallest possible number in workers that can still complete this task, and then we will cancel those 2 out. And then we will continue looking again, choosing the biggest available worker, and then continuing the algorithm until all tasks are completed. And if we are not able to complete the task, then we will return false and shift the right pointer. If we are, then we shift the left pointer. So first we see that 6 couldn't do 8, so we look for the smallest number possible that can still complete it, which is 4, because 4 can have a strength of 5 and complete 8. And now we look for the strongest available, which is 6. It can complete the hardest available, which is 5. And then 6 can complete 5 again. So it checks out. So we will temporarily set the result to 3. And then we will shift the left pointer, which is mid plus 1. So now we can test where middle is 4. Now first, we see that 6 is less than 9. So we need to take a pill. And we see that 4 is the smallest possible that can still match with 9 with a strength of 5. So 4 plus 5 is 9. So it matches. And now we move to the next one. 6 is our strongest. It cannot do 8. And we are out of pills since we already took 1 pill. So we know that it's false. So we shift the right pointer, which will be mid minus 1. And now that the left pointer is greater than the right pointer, we can return the result of 3. So the time complexity is quite long. So I'll just go ahead and paste it. So N will stand for the number of tasks. M will stand for the number of workers. So this part comes from the sorting here. And this part comes from the sorting over here. And obviously we will log based on the binary search, and obviously the binary search will be based on the minimum of M and N. So the first log will come from the binary search over here, and then within the binary search we will look through the number of tasks. So that's where this comes from. And as we look through these tasks, we will also use binary search to figure out which worker shall complete which task. So that's why it's log squared over here. And the space complexity would depend on which language you're using, but I'm using Python. So for my case, it would be N plus M because sorting these 2 arrays would take up N plus M space. So now let's get to the coding part. So first we will sort task, and then we will sort workers. Now we'll set the left pointer to 1 and the right pointer to the minimum of the length of task and length of workers. And we will set result to 0. Now we will set up the binary search, so while left is less than or equal to right, we will take the middle value, which is left plus right, and floor division by 2, and we would use a check function, which I will define it later, but we want to check, and if it is true, then we will set the result to the middle value and then shift the left pointer. Otherwise, we will shift the right pointer, which would be mid minus 1, and then return result. So now let's write the check function. So define check mid, and we'll keep track of the number of pills we have, and we'll set the variable to p, and we will make this works array, which will be the list of the strongest workers available. And now we will look through from mid minus 1 all the way to 0, because we're looking through the works array. So if the strongest worker available can complete the hardest task available, then we will just pop from works. We will just cancel out right away. If not, then we want to check if we have any available pills. And if we do have pills, if we don't have pills, return false. If we do, then we will take the hardest task minus the strength and look for the smallest element that can complete that task. And if the index that we end up getting is equal to the length of the works array, then that means no workers can complete that task, so we return false. Otherwise, we would just subtract the pill by 1, and then we will pop from index. And if we can make it through, then we return true. See if it works. Okay, perfect. Hope this was helpful. Thank you for watching. If you have any other questions or comments, feel free to leave it in the comment section, and I hope to see you all again soon.